Here we have learned about the iron and now check what is mild steel. Mild steel are actually um, the round bars which have no impression, just like this. These are the mild steel bar. These are the mild steel bar. IS 432 IS 432 describe about the mild steel bars. Describe about the mild steel bars, and mild steel bars are there is no impression like a CTB bar, that means cold twisted bars or HYSD bars. And now come to the point, what are the diameters of the mild steel bars? There are varies from 6 millimeter to 50 millimeter, 6 millimeter to 50 millimeter. And what type of bars are what type of bars available, for construction or any other case? There are mild steel bars, there are mild steel bars mild steel bars and HYSD bar, CTB bar, cold twisted bar, and TMT bar and TMX bar. Now let us discuss all of them. The cold twisted bars are used for building purposes, and TMT bar is thermomechanically treated bar. Now let us go to the picture of the thermomechanically treated and mild steel bar. These are the mild steel bars I have said earlier, and these are the cold twisted bar, HYSD bar. And these are the cold twisted bar. Why the twisting happens? Because twisting increases additional strength or ductility to the bars, Now according to the code, there are various types of properties of cast irons are available. Now let us check about 410. S is for soft. S is for soft, and WB is for weld purposes. FE410 is used for WB is for weld purposes, and 410 KB is for boiler purposes, WHT for structural purposes. You can check the codes to get details about this. Now come to the mild steel. Now come to the cast iron. There are various types of components available. Those are silica plus carbon plus sulfur plus phosphorus plus manganese. And the sulfur in the silica is 0.5 to 3%. Reduced solubility is increased also viscosity and reduce shrinkage. And more than 6% cast iron become hard. And the solubility is the sulfur content is 0.1%. It is an undesirable matter, undesirable substitute for cast for iron cast iron. So generally 0.1% is recommended. More than this makes brittle. Phosphorus is 0.1 to 1.5%. It increases the fluidity and helps to mix with other constituents. And manganese is 0.4 to 1% to increase the solubility. Excessive manganese can make shrinkage to the cast iron. Now wrought iron, what I have said, 0.5 to 3%, 0.5 to 3% in case of wrought iron, 2%, 0.15 to 2% in case of wrought iron, but in case of cast iron, 0.5 to 3%. Carbon is 0.15%. Sulfur here for cast iron 0.1% less than, but here 0.02%. Manganese is 0.1%, and phosphorus 0.12 to 0.16%. So now I have not said about the carbon content, but it is the most major product, most primary product for for varying the ductility of the concrete. Dead mild steel, in dead mild steel the carbon content is 0.15%, and in case of mild steel 0.15 to 3%. Medium carbon steel 0.3 to 0.8%, and high carbon steel 0.8 to 1.5%. Now HYSD bar has no definite yield point. Okay, no definite yield point. We have learned earlier that this is the stress strain curve of the iron or any kind of ductile material. These are the proportionality limit where the stress or strain are equal. These are the upper yield point also called rolling point, and the roll steels are made from this point, upper yield point. And C is cold twisting. Cold twisting is generally happen for by cold twisting B to C. B to C through this range, in this range the cold twisting generally happens. And after D, the ultimate Fu, we have got the stress Fu, and after it is breaking point. Generally at that point the necking happens. Before that, before the fracture, the necking happened. Before the fracture. So let us check, as there are some discussion I have discussed about the HYSD bar, and cold twisted bar. HYSD bar and cold twisted bar. The HYSD bar has no definite yield point, whereas cooler temperature makes the surface hard. This property is generally used for CTB bar, and twisting is happened due to the more strength when it is used in the construction purpose. TMT bar does not suffer loss due to the welding. No post-heating, no preheating requires in case of TMT bars. And in mild steel, the carbon content is 0.55 to 0.15%, and high steel bar 0.6 to 8%. The TMT bar, TMX bar, I have not discussed about the TMX bar. The TMX bar has more elongation than the TMT bars. Now, I have said earlier there is various kinds of notation. It is already asked in PSC, West Bengal PSC A 2020. And what is D defines? Define is for ductility. Fi value is for 500. The both yield stress is same, but in case of ultimate stress it differs. And the elongation is more. It is also more than Fe415. Cold twisted bars comparatively less weldable than TMT bars. D is for ductility, S is for seismic stability, and this code IS1, it is very important for to know about the steels HYSD bar, which are generally nowadays used. High steel deformed bars is described here. Now let us come to the bar dia. 5, 6, 8, 10, 12, 16, 20, 22, 25, 28, 30, 32, 36, 40, 45, 50 mm bars are available. The mild steel bar D less than 20 mm is 410 FU and Fy, and greater than 20 to 40 will be the yield stress, and ultimate stress is 410. Medium steel less than 20, 370. So if we increase the diameter by 20 mm, more than 20 mm, the the A5 value is decreased, and here also the 10% A5 value is decreased. In case of mild steel, this for we are discussing about grade 1. You can check it in IS 432. The mild steel spar are D less than 16 millimeter, D less than 16 millimeter, 540, which is AFU, and A5 is 350, and less than between 16 to 22, 540 to 340, 32 to 50, 510 to 330. Mild steel is low carbon steel, high carbon hard steel, and medium carbon steel. Mild steels give 800 to 300, 300 to 50 high carbon steel, and high tensile steel is 2000. There are various processes we gone through to creating a suitable steel for construction purpose, or any kind of structure such as boiler, for welding. There is various uses of steels. So there are few steps which are generally recommended for making the steel from the ore. The hardening is the temperature at the upper critical point. Hardening is done at the upper critical point. Tempering is done. Hardened concrete is hardened. The hard after hardening, the temperature is decreased, and at that point, the temperature will be below the critical point, below the critical temperature, and there the tempering is done, and annealing and heating and slow cooling is done at 500 to 600 degree temperature, and normalizing heating above critical temperature and cooling down rapidly below the critical temperature is called normalizing. The proof stress, it is generally used for friction grip bolts. The stainless steel chromium is 16% used for ball bearing. Nickel steel is 30 to 40% is for automobile purpose, and vanadium steel and the tungsten steel is for precision instrument measuring tapes, and manganese steel is for railway point.